Classic AutoSAR offers a standardized software architecture and development methodology that plays a crucial role in the software industry. It provides a common framework for organizing and developing software in order to facilitate compatibility across diverse vehicle models and hardware platforms. By promoting modularity, reusability, and standardized communication, Classic AutoSAR serves as the foundation for efficient and scalable software development. Automakers can leverage Classic AutoSAR to meet the demands of the increasingly connected and advanced automotive landscape, all the while improving safety and reducing the associated development costs. Classic AutoSAR was developed to address the evolving demands and complexities of automotive software systems. Over the years, there have been multiple releases of Classic AutoSAR, starting from AutoSAR Classic Release 2.0 to the most recent one, which is AutoSAR Classic Release R2211. These versions are developed to address evolving industry needs, introduce new features, and improve the overall architecture. They generally include minor updates and revisions to address issues and add enhancements. From Classic AutoSAR Release 4.0 onwards, there have been significant enhancements made to achieve goals in the automotive sector. Here's a look at what these pivotal enhancements are. With the emergence of Classic AutoSAR Release 4.0, came a well-defined layered architecture that provided a clear separation of software components and improved software organization. This release was in fact considered a significant milestone in the standardization efforts that were underway. Classic AutoSAR's layered structure is made of the application layer, runtime environment, and basic software layer. Each layer plays a fundamental role to ensure smooth operations across software and hardware systems. This well-defined architecture enhances software organization, promotes modularity, and simplifies maintenance. As a whole, this drastically brings down software complexity and improves adaptability to the evolving automotive software demands. For more on AutoSAR's layered architecture, check out our previous video. Classic AutoSAR Release 4.0 also emphasized a component-based approach to software development, which enabled the creation of reusable software components in order to reduce redundancy and improve code maintainability. This approach focuses on the creation of software components as independent and reusable building blocks. Due to this, automotive software is divided into discrete, self-contained units called components. Each one is responsible for specific functions or features such as engine control, navigation, or climate control. These components have standardized interfaces that define how they interact with each other, as well as with the underlying software platform. Developers can design and test individual components separately, which reduces overall development time and effort. These components can then be assembled like building blocks to create complex automotive software systems. Together, this provides flexibility and scalability while streamlining the software development process. In order to standardize communication protocols and interfaces, Classic AutoSAR introduced the AutoSAR communication stack. This ensures consistent and reliable data exchange between electronic control units within a vehicle. As a result of this, various vehicle systems can seamlessly and reliably work together. From the Classic AutoSAR Release 4.0 onwards, there have been significant improvements in configuration and parameterization capabilities. This allows for the adaptation of software components to different vehicle models and configurations without extensive code changes. Through this approach, adaptability to different vehicle models and configurations can be leveraged without requiring extensive code modifications. Developers can customize the behavior of software components by assigning specific parameter values to suit the unique requirements of each vehicle variant. This configurability not only streamlines the development process but also optimizes the scalability and reuse of software. It allows automotive manufacturers to efficiently tailor software components for various models, reducing development time, costs, and the potential for errors. Ultimately, this contributes to a more versatile and cost-effective software development process in the automotive industry. Classic AutoSAR in general, and mainly Release 4.0, incorporated additional safety features and improvements to meet the stringent requirements of safety-critical systems. These enhancements are owing to the standardized communication protocols and interfaces through the AutoSAR communication stack, which ensures consistent and reliable data exchange. Classic AutoSAR benefited from the development of a more robust tooling environment. This functions to streamline the software development process and enhance developer productivity. Commonly used tools and software platforms for classic AutoSAR development include Electrobit, Ep.3 Studio, Vector DaVinci Configurator, DSpace System Desk, and MathWorks tools for AutoSAR. This ecosystem ensures compatibility and consistency throughout the development cycle, from the time of requirements specification to implementation and testing. Classic AutoSAR and its many releases constantly adapt to the emerging trends in the automotive industry, accommodating advanced technologies such as advanced driver assistance systems, powertrain systems, and body control systems. All of this made it more relevant in the modern automotive realm. Classic AutoSAR is widely employed in numerous automotive systems and allows the implementation of critical functions and features in modern vehicles. For instance, it plays a pivotal role in the development of engine control systems, ensuring efficient combustion, emissions control, and optimal performance. It also underpins functions in advanced driver assistance systems, such as adaptive cruise control, lane keeping assistance, and automated braking, all of which increase vehicle safety and driver convenience. The lessons learned from classic AutoSAR have prompted the development of newer versions like Adaptive AutoSAR, which address the requirements of advanced vehicle technologies such as autonomous driving and over-the-air updates. Although classic AutoSAR set the tone for efficiency and scalable software development, it presents several challenges such as static configurations and not supporting dynamic software updates. Its architecture, initially designed for traditional electronic control units, may not be optimized for the advanced and highly integrated computing platforms required for modern vehicles, particularly those with autonomous driving capabilities. Reconstructing existing ECUs to meet AutoSAR standards can be costly and time-consuming. Also, adapting to classic AutoSAR's component-based approach and configuration methodologies may require significant training and expertise for development teams. With this in consideration, transitioning to more adaptable and high-performance frameworks like Adaptive AutoSAR reflect the industry's response to the automotive landscape of connected and autonomous vehicles. Adaptive AutoSAR emerged to complement classic AutoSAR by providing a framework better suited for these advanced automotive systems. It offers enhanced flexibility, real-time capabilities, and scalability, as well as increased connectivity and high-performance computing platforms. Next, we'll dive into everything you need to know about Adaptive AutoSAR to understand the flexibility and high-performance features it offers to keep up with emerging technologies and dynamic updates.